We are still with evaluating limits involving infinity. And here are more exercises, more examples. So, number one, evaluate 2x cubed as x approaches infinity. Now, applying the properties of limits, we can rewrite this limit as 2 times the limit of x cubed as x approaches infinity. So by substitution, we have 2 times infinity cubed. So, when you raise an infinity to any power or to an exponent, you get infinity. And if you multiply infinity by any number, you still get an infinity. Okay? So, here we have a more difficult example. Example number 2. The limit of x squared plus 4 over 3x squared minus 4x plus 1 as x approaches infinity. Now, from our previous examples, we need to show 1 over x. Okay? So we need to show this 1 over x in order to solve for the value of this limit. Okay? Now, this rational expression can be rewritten as x squared times 1 plus 4 over x squared. As you can see, this term 1 plus 4 over x squared is the quotient when you or the result when you divide the numerator by x squared. The numerator is x squared plus 4. And so when you divide these two terms by x squared, you get 1 plus 4x squared. So this numerator, this expression can be rewritten as x squared times the quantity of 1 plus 4 over x squared. Now we go to the denominator. The denominator can be rewritten as 3x squared times 1 minus 4 over 3x plus 1 over 3x squared. As you can see, this term enclosed in a quantity or parenthesis is the quotient, is the result when you divide the denominator by 3x squared. So this can be rewritten as the product of 3x squared times the quantity 1 minus 4 over 3x plus 1 over 3x squared. 4 over 3x is because when you divide it by 3x squared, you get 4 over 3x, canceling the term x. Okay? So, elaborating, applying the rules, so this becomes, by the way, as x approaches infinity, this can be rewritten as the product of the limit of x squared over, so we get this to 3x squared as x approaches infinity times, this is the dot product, the limit of 1 plus 4 over x squared over 1 minus 4 over 3x plus 1 over 3x squared. Again, as x approaches infinity. So, it looks complicated, but based from our previous procedures or methods, we only need to show 1 over x so that we can equate it with zeros. Okay, because 1 over x, when you substitute infinity for x, you get 1 over infinity, and that is equal to 0. So, okay, let's go into substitution. This term can be cancelled, so this can be rewritten as the limit of 1 over 3 as x approaches infinity. Okay? Now, and this is multiplied by, so we have here the limit of, this is a constant, 1 plus 4 over x squared. So here we have 4 times 1 over x times 1 over x, and that will give us 0 over, again we have here 1, again 4 over 3x, so that is the product of 4 over 3 times 1 over x, and 1 over x is obviously a 0. So we are now into substitution, so we might as well erase this limit statement here, plus 1 over 3x squared, again this is a 0. So here we have the limit of a constant, which is 1/3. Okay, times 1 plus 0, we get 1 for the numerator, and 1 minus 0 plus 0, we get 1 again. So here we have 1/3 as the value of this limit. Okay?